Hello gentlemen, welcome back. This video is going to focus on dividing polynomials using a technique called long division. Again, hopefully you guys have seen this. We're going to learn two types of division here. We're going to learn long division and we're going to learn synthetic division, which is going to help us to ultimately find our zeros. And that's something of particular interest as you've seen. But let's look at three examples today. We're going to do three examples in this video. The first one is I want to divide this polynomial 8x cubed minus 10x squared minus 37x minus 15 by 4x plus 5. And I want to use that result to completely factor this polynomial and to find the zeros of this function. Okay, so let's start by doing long division. And so hopefully you guys have seen this type of notation before. And basically the first step is, what do I multiply 4x by to get 8x cubed? And what you should see is it's 2x squared. So if I multiply this by 2x squared, what I'm going to get is 8x cubed plus 10x squared. All right. The next step in long division, hopefully you guys remember long division from your grade school days, but the next step is to subtract. And so this term is going to cancel out, and we're going to get negative 20x. We have to change signs here. Okay, so I get negative 20x squared, bring down these other two terms. Okay, next step is, what do I multiply 4x by to get negative 20x squared? And hopefully you realize that I got to multiply this by negative 5x. And if I do that, I get negative 20x squared minus 25x. Okay. Again, I'm going to subtract, and this term will go away. I'll get negative 12x minus 15. And now I have to say, all right, what do I multiply 4x by to get negative 12x? And hopefully you guys realize that that's just simply negative 3. And if I do that, I get negative 12x minus 15, again subtract, and I get 0. That means I don't have a remainder here. All right, so this is a perfect factor of this polynomial. So I can rewrite this polynomial with its one factor, 4x plus 5, and this other term, let me go to the previous, which is right here. So this times this gives me this thing inside. All right, and that's where this comes from. Now I want to factor completely, so I can factor this a little bit further, and that's going to allow me to find the zeros. I can factor this, hopefully you guys can see this back from Algebra 2 days, that this is just simply 2x plus 1 times x minus 3, this part right here. And now once I'm in completely factored form right there, I can simply find the zeros, because one of these terms is going to be 0. Okay, either this term is 0, this term is 0, or this term is 0. All right, and again, at most we can have 3 zeros here. So let's keep going. So if I set 4x plus 5 equal to 0, that means that x is equal to negative 5/4 is a 0 of this function. If I set 2x plus 1 equal to 0 and solve, I'll get x is equal to negative half. And then finally, if I set x minus 3 equal to 0, my 0 here is going to be x equals 3. I have 3 zeros here. Okay, all of multiplicity 1, which means if I was to ask you to graph this, I would go through each one of these points. I have a positive leading coefficient, so the end results here are going to be something coming up here, something going around down there, and then I'm going to go through each one of these points. Okay, let's do another example. 6x cubed plus 10x squared plus x plus 8. Divide that by 2x squared plus 1. Okay, let's look at this. If I do this here, I got to ask myself, what does 2x squared, what do I multiply 2x squared by to get 6x cubed? Well, I multiply that by 3x. And then if I distribute through, I'll get 6x cubed. I don't have anything here, but I want to line things up carefully. And then again, I'm going to subtract. I'll get 10x squared minus 2x plus 8. Next step is, what do I multiply here by, what do I multiply 2x squared by to get to 10x squared? and that's simply 5. If I multiply through, I get 10x squared plus nothing under this column plus 5. Again, I want to subtract negative 2x plus 3. Now I say, what can I multiply this by to get this? I can't, because this degree is higher. So this term right there is my remainder. This isn't going to be a factor, and so I'm not going to be able to use this to completely factor and find the zeros. So in this situation, I have a remainder. So how am I going to write that? I'm going to write it as this term divided by this one is equal to this plus my remainder. And to do that, I write it like this. Okay? This, get rid of these, this is my remainder term. I write my remainder over the dividend right there, okay, or the divisor right there, okay? I write this term, this is what I started with. I took this divided by that. I got this whole part here, and then this is my remainder, okay? Let's do one more example. I want to divide x to the 4th plus 3x squared plus 1 by x squared minus 2x plus 3. Be careful here, because I want to leave some spaces because there's no x cubed term and there's no x term here. So I'm better off leaving some spaces here and here. Okay? What do I multiply x squared by to get x to the 4th? I multiply it by x squared. Then I multiply this term by each one of these. And there I have that. Now what I want to do is subtract. Okay, the first leading term goes away. I get 2x cubed. This term actually cancels out. Plus 1, bring that down. What do I multiply x squared by to get 2x cubed? Well, it's going to be 2x. Again, multiply the 2x through each one of these terms. 2x cubed minus 4x squared plus 6x. Again, subtract. What do I multiply x squared by to get 4x squared? That's simply going to be 4. Again, multiply through each term. 4x squared minus 8x plus 12. Again, subtract. I get 2x minus 11. Can't go any further. Degree here is greater than the degree there. So that term right there should be my remainder. And if I write it out again, I'm going to write this over this term equals x squared plus 2x plus 1. And that's my remainder right there. Okay? Here's some practice problems, fellas. I want you to look at those 3 examples. They're pretty good. They'll help you understand how to do this. Here's a few problems to practice, and this stuff should be pretty straightforward. If you have questions, make sure you email me. All right, gentlemen? Have a nice day.